Kia ora Year 12. This video is going to go through the complex numbers and vectors questions from the school exam. So the complex numbers one had 4 parts to it, and they all led right through to part 4. So we're given this complex number w, which is -1/2 plus I times √3 on 2. And straight away you should want to draw that into a diagram. Okay, and we're going to have to find the modulus and argument of that number. And then reading through the question before we start, we're given another complex number, which is looks like it's just r cis theta. And we're told something about where that's sitting. We have to state the modulus and argument of that complex number. Of wz, and the modulus and argument of z over w. So straight away you should be thinking that when I multiply two complex numbers together, I multiply the moduli and I add the arguments, and the same result for division. And if you can remember that, then that's a really easy 4 marks. But it also is going to help us a lot with this question down here. And then we have to explain why these points are the vertices of an equilateral triangle, which sounds hard, but it turns out it's not if you do this bit well. Lastly, we're given a specific complex number. We're told that the vertices of an equilateral triangle lie on a circle with centre at the origin. And one of these vertices is this complex number 4 plus 2i, so about here. Find where the other two are and give your answers in this form. So you've got to figure that that stuff up above is probably going to help us to do that last bit, and it does. Okay, so let's get going with it now. We'll just open up a new page. Right, so we've got w is equal to -1/2 plus I times √3 over 2. So sketching it shows us straight away that we're here and we're up here. So this is -1/2 and this is √3 on 2 up here. And your brain should be screaming at you special triangle, because it's just a shrunk down 1 √3 2 triangle. And that means that I know straight away that this angle in here is 60 degrees or pi on 3, and the angle we're after, the argument, is going to be 2 pi on 3 or 120 degrees. So the modulus of w is equal to this. So the modulus of w is 1, and the argument of w is equal to 2 pi on 3. Now I would put from graph and special triangle. Right, so you can draw this nicely and just say -1/2, here's the origin, √3 on 2, and then 2 on 2. And in here we've got pi on 3, and so here we've got arg w. The other way that you can go here, which a number of you did, is you can go mechanically without drawing your graph. Arg w is equal to tan inverse of the imaginary bit over the real bit. But as you know, many of you forgot then to make the adjustment that you need when you're not in this quadrant down here, right? So if you're down here, just the tan inverse is going to give you the right answer. But remember, you need to make an adjustment if you're up here, because your calculator just isn't recognizing whether you've got √3 on -1 or -√3 on +1. So I know that I've said this 1,000 times, but too bad. Just draw the picture, okay? And if you read the examiner's report, they say the same thing, that not enough students are drawing the pictures. So there you go. So that's the first part done. Let's have a look again at the question for, where's it gone? Right, so now we've got this mysterious generic complex number. Z is modulus r and arg theta. And we have to go through and find wz and z over w. Okay, so z is r cis theta. We can use the result that we're going to multiply the moduli. And so we've got r times 1, which is just r. And the argument of zw is equal to argw, or argz plus argw. So that's 2 pi on 3 plus theta. and then z over w, well, we can divide the moduli by each other, and we get the modulus of, have I done that the right way around? I think that's not what I need to do. Hang on, what's z? Yeah, that's right, sorry. Z has modulus of r and w has modulus of 1, that's right. And so this has also got a modulus of r. And the arg of z over w is equal to the arg of z minus the arg of w, which is theta minus 2 pi on 3. I think when you learn those results when you're in the middle of complex numbers, they seem just about trivial because they're so easy to use, but they can really help us to simplify all kinds of complex numbers problems, especially when we're trying to work out angles and other geometric things. So what we've got now is first of all, we've got 4 very easy marks, but we can also see what's going on is that we're now saying that if we've got some complex number z here, well, z has a modulus of r, and zw still has a modulus of r. If this angle in here is theta, then z times w is r rotated around 120 degrees. So I'm going to try and draw that, and I'm probably going to muck it up. So there's 90s about there, so a little bit further onto there. So there you go. There's your zw is here, and z is here. Now, what about z over w? Well, z over w still has a length of r, but it's been rotated the other way 120 degrees. So I'm trying to draw, what I'm trying to do here, because you know how bad I am at drawing, is I'm drawing roughly my 90 degrees, and then I'm going a tiny bit further. So it's going to be about down there like that. And that's also got a length of r. Now that picture is just a dog's breakfast, but it actually is enough, especially if I just erase that one and draw that one better. So if we do this like this, and now we're just going to take our ruler and we're going to join up those vertices, and you'll see what's going on, and that should help you. Oh, where did it go? It will help you answer the question better, right? Because the next question is where we're asked to say, how come this forms an equilateral triangle? So what can we say? Well, we can say that we've got 3 points, all are away from the origin, and we've got the angle in here is 2 pi on 3. So I'm going to do some labeling here. So this angle is 2 pi on 3. So triangle AOB has got, it's an isosceles triangle, right, because this is length R. And angle AOB is equal to 120 degrees. What else can I say? Well, that means that angle OAB is equal to half of what's left over, so half of 60 degrees, which is 30 degrees. And angle ABO is also equal to 30 degrees, right? So that's both because of base angles in an isosceles triangle. And we can do the same thing similarly for triangle OBC and OAC. So that means that each of these angles must be 30 degrees, and each of these lengths is also going to be equal because these sides are the same length. Okay, and length AC is equal to BC is equal to, what's the last one, AB, since AO, BO, CO are all R long. Okay, so we've got side lengths are all equal because all of the angles are the same at the center and the lengths are all R. Okay, but the best thing to do this question is to have a decent diagram like the one we've got here. It doesn't have to be totally to scale. Now then, the last part of this question was where we had to use it with a specific complex number, which is this one here, 4 plus 2i. We have to find the complex numbers represented by the other two vertices. And again, if you've got a good diagram here, it's really easy to go, oh, well, this first point here, we can think of it, this is 4 plus 2i. How do I find the other two? Well, I want to rotate by 120 degrees that way, so I need to go ZW. And then for this one, I'm going to have Z over W. So the other 2 points will be these. ZW is equal to 4 plus 2i times negative 1/2 plus I times root 3 on 2, which works out to be negative 2. Just do it without talking. So there's that one. And then Z over W is slightly more work, so 4 plus 2i divided by W. Sorry about the noise in the background is the dog snoring, just in case you're wondering. It's not me snoring. Okay, so cleaning up the bottom line. Here we're going to get 1/4 plus 3/4. And then the top line we have the numerator, also called the numerator, negative 2 minus I minus 2 root 3i plus root 3. And all of that cleans up to give us a really nice complex number, which is negative 2 plus root 3 plus I times negative 1 minus 2 root 3. Okay, look, I'm not going to do the vectors question in this video, but I am going to talk about some things in the examiner's reports on complex numbers questions. And one thing that they're obviously noticing is people trying to do these questions with calculators. Right? So don't even bother, right? You just won't get any marks here unless you end up using your brains and getting exact values. Some of you made some pretty amazing attempts at doing this in polar form, but you would be better off just to go back to the question and try to really get the hang of the first part. And you can see that if once we'd understood that big idea about having the 120 degree angle, and you can see that we're going to be rotating, that fourth part is just not too bad. Okay, so for people who turned up here wanting the vectors question, I'm really sorry, you're just going to have to wait a little bit longer. I will do that in a separate video shortly.